Hello there, welcome again to my channel. In this video I'm going to show you how face recognition technology works and how you can use the available pre-trained face recognition model to recognize any face images or video. Since I'm going to keep this video as short and simple as possible, I'm not going to dive deep into the actual development of the face recognition model. I'll just use a pre-trained face recognition model to recognize the faces that I have with myself. Before I jump into code, I would like to give you a little bit of the theory so that you would understand how the face recognition works under the hood. Basically, face recognition is trained on a huge data set, and the way it works is it combines a bunch of technology. We have the deep learning model and we have the face detection model and face alignment. So, image that you give to the face recognition model, it goes through 3 steps. The first step is that it detects face in the image, which is in this case, since I'm using a pre-trained module, it uses another library called DLab for face detection. Like if we have an image and then the DLab detects the facial points so that we can crop the face part. In the second step, it aligns the face. Like sometimes in an image the face might not be at the center of after the detection, it's not at the center, or it's a little bit rotated. So all this alignment is done in the second step. And in the third step, the face recognition gives this image that we have, and then we have a bunch of encoded images that we will use how to encode the images, and then extracts 128 features and then compares these features. So if the features matches, it means these 2 images are close to each other, which in other term we could say that the distance between these 2 images are very low, and by distance we means Euclidean or L2 distance. And if it is very low, then it is actually same faces. That's how it works. If we come to this figure, we can see that we have a picture of Chad Smith and then we have 2 test pictures. So basically, once we train the model and when we give the pictures, it compares the picture with the non pictures. And if the feature of this picture actually matches with this picture, then we can say, yeah, these are the same. And if it doesn't match, then this is not the same. So it's not well feral in this case. And that's how it works. And the way it detects 128 features is like this. So again, I'm not going to explain details of this extraction, feature extraction, because I want to keep this video short. But if you are interested, you can go through some of the latest paper available for face recognition or articles over there. And then if you have more, if you want me to write to create a video for face recognition, then like the details of the face recognition, then please write it down in the comment and I will check that. Then I can create a new video on face recognition. Alright, I think it's time that we jump to code to see how it works in actual. So the first thing you need to do is to install face recognition module and create a new environment. In this case, I have this environment activated, and then write pip install face recognition. So the face recognition module in here accompanies all the required libraries, so you don't need to really worry about anything else. Like it has NumPy, dlib, some alignment, encoding, and etc. It's all packed in this module. Let's install it, and after it gets installed, all you need to do is to so I created a snippet of the code to keep this video short because it will take time to write all the code. What we need to do is we need to create a class. I call it face recognizer, and initialize it with two lists of non-encoded faces and non-names. And then in this class we have two functions. One is encode image, and then we have detect non-faces. We get the images path. I use globe. You can use any other module like path itself to read images, and then we want to find the number of images, how many images we have read. So what is this image? It is basically the images that we want to compare, or we want to recognize the faces. So think of it like as a reference images. We have these reference images, and then we keep these images and tell the model that any faces that you will get afterward, compare it with these images, and if it matches, gives it the name that is already in like the image name that we have stored. So if I come to here, we have the image of Dwayne Johnson, we have the image of Elon Musk, and then we have the image of Gal Gadot. So these are the three images that we are interested to compare, and I have a short video that I'm going to use. This is the video. I'm going to use this video so that the system will recognize the face of these characters. So we get the image paths, as I told you, these three images that we will use as a reference to recognize faces. We loop through each image's path and read it, and then we have the base name that we use, OS path base name, to get the base name, and then we remove the extension, which is the JPG or JPEG, and we get the file name. And in here I have the face recognition module, which I imported above. Using this module, all you need to do is to use the method called face encodings. We use the face encodings to encode our image and keep it. I'm going to keep it in here, non-encoded faces. So we encode these images, and then we get the first index, which is the highest one, and we add these images into this list that we initialized above. So we have 3 images, and then we encode all these 3 images and store it into our non-encoded faces. And also the name of the image, which is basically Dwayne Johnson, Elon Musk, and Gal Gadot, we keep it into another list. In here, what we need to do, we create a new function call it detect non-faces. Then we pass our frame, and then since real-time frames are too large and it's sometimes very hard for the model to consume it, we're going to resize it to a ratio. So this is the frame scale. This is another piece of code. It's kind of same for all real-time applications. We have this video capture where we have our video path, and then we try to read each video, and by pressing the try to read each frame of the video and show it one by one, and by pressing the Q button, the the loop will break, and then we release the camera resource and destroy all the windows. So this is kind of static. I don't want to like write it and then take your time, so I'll just go for the actual piece of code, which is detect non-faces. So to detect non-faces, first what we need to do is let's make our frame smaller. So we call it smaller frame, and to do that we need to write cv2.resize, and then we pass our frame here, and then we give it not this kind of sizing, but we use the fx, which is frame scale, and fy, which is also the frame scale. And since the face module reads images in BGR format, but the OpenCV uses the OpenCV uses BGR format to read images, but the face recognition module uses the RGB. We need to convert our BGR to RGB images, and I'm going to keep it back in the small frame, and cv2 dot convert color. We have smaller frame, and then the code cv2 bgr, bgr 2 to RGB. So we converted our BGR images into RGB to give it to the face recognition module. The next thing that we need to do is to get the face locations. To do that, there is a utility function available, so we need to use face location using the face recognition, and face location a utility function, and then we pass our let's make this like this, RGB, to be clear, and then we pass our RGB smaller frame, and that's it. We get the face location, and then we get the face encoding. Let's get the face encoding, and then we have another utility function available in the face recognition module, which is called face encodings, and then we pass our RGB small frame, and then in here the face location that we detected before, we are going to pass it here, so we give it the face location here. So if I explain it again, we pass our frame, and the face recognition face location function finds the face like a rectangle, and then we get that face rectangle with the frame and give it to the another method of face recognition, which is called face encodings, to find the to encode our images. Alright, so let's get the face names. Let me just create a new list, initialize a new list, and then we say for face encoding, in face encodings, let's give an S. Then what we need to do is to find the base match. So we say matches face encoding, and then so we get the face recognition model, and then we say compare faces. So we have our faces to compare. So we have the self dot none faces, the none faces that we have created before. So we say self none faces, which is here. So we have our non-encoded faces and then the encoded faces that we get from each frame. So and by each frame I means in here. So this is the face encodings. So we get each face encoding and then compare the result. So I'm gonna call it non-faces, and then I'm gonna pass the face encoding. And then after that, what you need to do is to check you need to get the based match out of the matches that you'll find. So to do that, let's estimate the distance. So to get the lowest distance, what we need to do is use another utility function from the face recognition called face distance, and in here we pass our face encoded non-encoded images. So we call it self dot non-encoded faces, and then we pass our face encoding. So we found the matches and the face distance. Again, if you print out the face encoding, it's 128 features that I showed you at the beginning of this video. So what we need to do now is to find the base match among the faces, and let's just write it base match index, and we use the numpy argmin, and we use the face distance in here, which is basically the minimum distance. We want to get the index of the distance which has which is minimum. So we use numpy argmin to get the index that has the minimum distance between two faces, and we say if matches, we pass our index in here, base match index, then we say name self dot, and then we get the names that we encoded at the beginning, which is non-names, and then we get it by the index, and then we say face name dot append name. So we got our name here, let me create one more name in case our system couldn't detect it detected the face but is not sure that whether it is one of the faces that has been already encoded or not. So let's give it an unknown value in case our system couldn't detect the right face, and then we convert that to numpy. We say face location and numpy dot array, and then we pass our face locations, and this has to be face locations. Yep, like this. Yep. So we encoded that. What we need to do is to return it. So before we return, let's to show the bounding box, let's like reduce the, since we are going to scale down the frame, let's scale down the location of the face location as well, and we say face location is equal to face location divided by frame scale. And finally return face locations let's keep this like this. Face location dot as type integer and then face name. Yep. So this is the important function that we need to use, and then let's see how we can use it into real implementation. To do that, before we show our image, let's detect our face and face locations, and then put the name that we got and put the bounding box and then visualize it. How are we going to do that? So we say face locations, and face names. Okay, before we need to, we have the image path and we have the video path. So let's create a face recognizer object, and we have face recognizer, and then we say face encoding. Since I have a comment here, let me write here face recognizer dot face encode image, and then we pass our image path. And then we get the face locations and face names using the face recognizer dot detect non-face. We pass our frame, and then I'm going to scale it down to 0.25% of the actual frame. The next step is we are going to loop through each locations. So we say for face locations and face name, and then we are going to, since we are going to loop in two lists, we are going to loop through two lists. We are going to I'm going to use zip. So let's zip our face locations and face name. That's it. The next step is we need to find the, we need to get the each face location. So the way the face locations are returned by face recognition module is y1 x2 y2 x1. So we say y1 x2 y2 x1. That's the order that defined in face location. And we say face location 0, face location second index, face locations third index, and final index. So let's say cv2 dot rectangle, and then I just want to define whether it's really working or not. So let's put a rectangle, and that is cv2 rectangle. We have our frame, we have x1 y1, remember the type of these must be integer. That's why we convert it to integer. So x1 y1 as a 0.1, and then we have x2 y2 0.2, and then we define the color. I'm gonna give it a 0.0200, the color code, and the thickness. That's it. Let's run this piece of code, and if detected the face, then I'm going to use this face name to put the name of each person on top of the face. Let's see how it works. So we found 3 encoded images. Yep. So we are able to detect the face. The next step is we need to put the name that we got onto the face. So to do that, let's say I'm going to put it here, cv2.putText, and then I'm gonna pass the frame. And the second thing that I need to do is to define the location, the text, face name, and then the location I'm gonna give it as a x1 y1 minus 10. So it's like just a little bit up on the bounding box. So y1 minus 10, just 10 pixel above the bounding box that we detected. And then we have the cv2.font. Let's say I'm gonna give it a font Hershey Duplex, and then I'm gonna give it 1. Then the color code, same like the bounding box, and I'm gonna give it a thickness of 2 for the text. Let's see how it works. Yep, as you can see, we are able to detect the face. Cannot unpack non-iterable non-type object. Let me see, we got an error here. Alright, let's see. Okay, so face locations, I think there is a problem with the detect non-faces. In the function detect non-faces, if we come here, okay, since it is returning non-type, okay, you need to, this part of the code must be out of the loop, so that it returns all the names that we have, even if it doesn't detect the face. It fails to recognize the face. It still should gives us an unknown label. Let's run this again and see how it works. There you go. We have the face and the detection and also the recognition. As you can see, it is not very it's not real time at all, and it's not very optimized, but I hope you got a understanding of how face recognition works, and in particular how you can use the face recognition module available for Python. You can certainly improve the FPS of this video. You can do either to replace the dlib, because in this video in the face recognition module uses the dlib, and that is slow. It needs a lot of memory to detect the face, and also the face recognition module also needs memory to recognize, to match the faces and compare the distances. So that's why it's not real time right now. What you can do is to, if you want to deploy this kind of solution into real environment, I would suggest you to use another face detection deep learning model to detect the faces. There are new models which are very light and simple, and it takes much lesser memory than DLib. I can give you a simple example, and that is MediaPipe. It's a Google custom framework for many purposes. You can detect faces, body pose, and many more. And then you can train a simple face detection algorithm, face recognition algorithm to recognize that. If you're interested for that video, and if you want me to create another video on detecting faces and recognizing faces in a more higher FPS, please write it down in the comment section below, and I'll certainly search more for contents and face models and give you the best one, the optimized one, so that you can run it in real time without any problem. Again, I'm going to emphasize that I kept this video as simple and short as possible. That's why I'm not going to dive deep into the details of the actual face detection and face recognition models. But if you're interested, please write in the comment section, and I'm gonna create a new video to describing how these models actually work and how you can improve the FPS and how you can improve the accuracy. Right now you can see that in some cases it cannot detect faces. It fails to recognize a face. So to improve the accuracy and to improve the efficiency of the system, face recognizer system, there are methods available and we can implement that. That's all for this video. Thank you so much for watching, and I hope it is helpful. Please write down in the comment section below what you want me to create for the next computer vision project. I will appreciate that, and I will certainly check that, and I'm going to consider that. Thanks again. Have a good day.